going to go ahead and get started. So this session is about Azure. Half of my local audience here is the computing committee, so I'm going to solicit stuff from them when we have specific questions answered or asked. What I want to talk about today is getting you started with Azure if you happen to need it for your computing projects. What exactly the sort of requirements are for requesting time on our Azure allocation to run those projects, what kind of resources are available there as opposed to the supercomputing center or our hydras, how to connect to them, and how to properly use them so you can make the most out of your grant that we've been given. So one of the key places to start is, as always, the computing wiki. Please visit there for any of your computing questions before contacting us. You may very well find your answer there. So the first thing that I want to talk about is the general framework of Azure and our computing and how it fits into our computing tiers. So last week, or 2 weeks ago, we talked about our campus cloud environment, which is really just a bunch of virtual servers sitting over in Syrett Hall. Another piece that we'll talk about in a couple weeks is Access, which used to be Exceed. That gives us access to the Pittsburgh Supercomputing Center, as well as the Texas Accelerated Computing Center, the San Diego Supercomputing Center, and numerous others around the world. But that will be in a couple weeks. So I just wanted to give you a physical idea of where things were. We have on campus, we have Supercomputing Center, which is out in Monroeville, and then we have Azure, which is all over the world. So if you start up a virtual machine, you will be one of these millions and billions of computers that are spread in different zones across a region, like North America. So you might have North America East, North America West, Australia, Southeast Asia. There's about 15 or somewhere between 15 and 30 zones at any given time. So you can actually control access to your servers if you need to based on that. That's more of my concern than yours. You can tie them together in many different ways. So a couple general notes about Azure. This was based on a relationship that we built with Microsoft, sort of in a back channel. So this is not directly handled by the university. This is handled by our department and Dietrich to help facilitate the communication. This is also part of an internal project at Microsoft. So we don't have necessarily enterprise support from their team. We don't have access to necessarily all of the resources that Azure provides. And I'll talk a little bit more specifics in just a minute. What we do have is direct access to a tech support person who can help us with specific issues. That said, that person has turned over 3 times in the past year, so even though we have a direct line, it is sometimes a challenge to get the right person on the line. And that can take some time. So like with many things, last year we went through a transition with our help desk system and our website, and this year we're going through a transition with Pittsburgh Supercomputing Center and Azure. So they're updating the interface and the way we can assign resources to you within the administrative interface, and the way you can request them once you have an account there. I don't know what that looks like yet, but we will know within the next 2 months, I'd say, about how to best use that. The new interface will actually not go live until sometime in the spring, maybe even May. So for the time being, we're going to keep our current request process in place, which I'll talk about a little bit later. But you basically come to us as a computing committee or the remarks group. We review your process for your project, and then we'll provide you the resources that you need. So to go along with that, I have to be very specific about the type of support that we give. We can help you get a virtual machine set up. We can help you attempt to use everything that Azure advertises, but we do not know what we don't have access to. And that's been a really frustrating point for us. Hopefully that will be resolved in the spring. One of the things that we found we did not have full access to is unlimited GPU machines, for example. So we have a fixed amount of GPU resources that we could use. We've also encountered different programming frameworks that people have wanted to use, and I'll mention those in a minute also, but we don't always have access to something that somebody on GitHub might have put together for a parallelization project, for example. So if you see something neat somebody's done, we can't necessarily use it with Azure. So I'll be on hand to help you negotiate those. So this is a cloud computing platform, which is great. It gives us great flexibility, great power. We get to choose the type of resources that we want, whether or not it's a machine with 85 processors or 2 terabytes of RAM for an arbitrary amount of time. That said, you have to be responsible for maintaining that machine. So you sort of become a system administrator, and again, I'll help you with that. So it's a little more intensive in terms of a learning curve. It also requires you to monitor your usage a lot more closely. One of the things that we did not get or don't have full access to, as I stated in the support statement, is full use of monitoring and metrics that are built into Azure. So Microsoft has a whole ecosystem of projects, which I'll also show you a screenshot of. But we don't necessarily have the ability to use fine-grained monitoring to make sure that we're optimizing our resources to the max. So you have to basically be mindful of turning on your computer when you're using it, turning it off when you're not. And again, if you go to this link that I've nicely copied and pasted on the second page here, it will help guide you along with that also. So I mentioned a couple items as to why you would want to use this or when you would want to use it. So with the Hydras, that's a great place to go ahead and play and learn Linux and use them as much as you possibly can for your current jobs. Do parallelization across a cluster. They're static resources. They're always going to be there, regardless of how you might have to fight over them. But Azure offers us the opportunity to specify exactly the resources that we want for a specific project. So the Hydras max out at 128 gigs of memory for a single machine. If you need more memory, you can go to the supercomputing center. This might be faster to get a machine started. You might not have to wait in a queue. Basically, if you need a dedicated server quickly for a particular project, or if you have a long-term project where you are going to be able to manage the computing resource yourself. Some of the projects that we have currently running on it or have run on it are simulator-based inference for particle physics, structural forecasting for tropical cyclone intensity guidance, and spatial arc models for handling non-Gaussianity in ocean temperature data. And you can tell I don't use these terms a whole lot. So if anybody else wants to offer that, or if you have questions about them, I can send you to the right person. But upcoming, we have 5 projects in statistical methodology, 3 projects in statistical climatology, and 4 projects in biostatistics. So these are just computers. They serve a wide range of purposes. We will be providing access to a request form for these. Usually we do a request on a semesterly basis, but I think we're going to open it up. So if you need a very short-term usage of one of these resources, then you'll be able to request it, and we can fit you in. So what's available on Azure? These are 2 of the 10 or 12 different sections of the ecosystem. If you're familiar with AWS also, they have 100 different services that you can use to tie together. I will say generally they're mostly targeted at application developers, not necessarily research coders. So you'll find a lot of research-based resources on places like GitHub and other independent projects people have created. That said, some of these may be useful for you. So they have high reliability database servers for Postgres, MySQL. They have NoSQL databases you can use. They have the ability to easily construct virtual clusters. and they have a whole other, these are the categories that all these resources fall into. So at the top, fortunately for us, is AI and machine learning. They have a machine that you can, a machine image that you can spin up very quickly that I'll demonstrate in a second. That has all the ML tools built into it, so you can train some models. They do have an analytics section, which is a little more targeted at non-statistical analytics. But you'll see a lot of them are developer tools, management tools, infrastructure stuff, servers for creating a media streaming environment. These things we don't need. But you're welcome to log in and peruse those whenever you want. Yeah, so I mentioned the problem with using some of these things is that we don't necessarily have access to all of them, but we don't always find out what we don't have access to until we try to use them. One example that we ran into, that we were just talking about in our meeting, is creating a ML workspace, right? A machine learning workspace. This is the concept of getting all your resources together for a particular ML project. And there's a very specific way to write one configuration file that ties all these together and then automatically does it, or runs your job. So unfortunately, you have to learn what a lot of these pieces are yourself before developing that configuration file and running the job. We also, in the past, one of our users did not have access to do this. We're still not sure if everybody does in general, but I do, so they had to come to me to specifically request access. So a lot of these capabilities are role-based as well. As always, send email to remarks@stat or visit us during office hours to investigate any of these questions you might have. Some of the other things that haven't worked in the past that people thought were really cool and useful was a library called Do Azure Parallel, which somebody created specifically for R to run parallel jobs and scale them automatically on Azure. That still does not work because our specific account has just limitations on it that they can't change. We're hoping that changes with our migration to the new interface, the new education hub. So we'll know more about that in the spring. Let's see. So I mentioned the monitoring metrics. We do also have a limitation on the types of servers that we use. So I'll show you that when we actually go and try and set up a server. But there's about 20 different types of GPU cards, for example, and we only have the ability to access 3 or 4 of the different types. And it took me about 3 months of going through tech support at Microsoft and our contact to figure that out. Because unfortunately, due to our type of scholarship that they've given us, they call it, they don't actually have documentation on what we do and don't have access to. They're discovering this themselves. Right, so your first touching of Azure comes to resource management screen. So when you first log in as an end user, this is basically what you'll see. It'll ask you for starting your own trial. You get up to $200 worth of computing with that. I have access to manage the sort of directory structure, which allows you access to the other resources. But there's other student benefits, such as training, documentation, et cetera, that you can view here as well. Once you get these out of the way, this is the menu that you'll see along the top. It's got basic resource management. Everything in Azure, from your point of view, is considered a resource. So whether it's a sort of a group of things, a lab that you've set up for people to use in class, a virtual machine, network interface to a virtual machine, a security group, everything's called a resource, and you just map them in different ways. So that's your primary interface, which I'll demo in a second. The other key thing that you need to know is how to use these things responsibly. Basically, from your point of view, what I said is turn off your virtual machines when you're not using them. If they're on, we will be charged for them. You get a number of credits when you propose a project, and so you are also responsible for monitoring those yourself. I will catch you when you go over that, So it's much better if you stay underneath your project limit. Double check exactly what you're doing, make sure you are in the right machine, you're not turning off some other resource that you have. Yeah, let us know if you notice anything strange. If your machine isn't shutting off, if you are suddenly noticing that your machine is using too many credits, if you've written a batch processing script and it's gotten out of hand, it's using, all 5 of your servers that you've set up, and it should be using one, we are available to help answer those questions. And at that point, you've got your machine set up, you're running, you've done all this responsible stuff, you now have my job, you're a system administrator. So, hopefully you won't get better than me and take my job. So again, where to get support, we have our wiki, but Microsoft also actually has really well-written documentation and tutorials. So here's 2 separate links that go to different places, even though they say the same thing. And office hours for us. And we can schedule not just for us, but for you to have a meeting as well. If we can't figure out something with tech support, we're happy to sit in there with you with our tech contact there. So are there any questions at this point before I jump into a quick demo of how to set up a virtual machine? Yes?
Will the new educational hub mean that I will not be able to spin up an instance myself?
No, actually, the new education hub will give you more control,
Okay.
not less. And it should be, so we met with the actual Microsoft representatives on campus. They had this project that they've given us, free credits for. They're working with engineering, HCI, and we're sort of actually on the side. We got in at the last minute or something. So they've been conducting research for the past couple of years on how to make this work better for everybody, and that's what the education hub is coming out of. So we've all complained about the same thing. We've all complained about not having resources even when they're presented to us. We've complained about not having enough GPUs. They said they can't fix that, unfortunately. So they've taken a lot of our feedback into account over the past 6 months, and yeah, ultimately it should result in you having more control and understanding of what your machine is doing at any given time. Thanks. Any questions on Zoom? Nope. Okay. I'm going to jump right into showing you the interface for creating a VM and sort of some of the terminology that goes along with the interface. So when you do have a tech support ticket, we can all be talking the same language. Switch back to mirroring the displays. There we go. All right. So this is my administrative interface, and it looks basically like yours. I have a few extra options on it for role management, user management, things like that, work group management. But when you're logged in, you will have, again, that same bar across the top that has the primary things. You can customize that. If you click on more services, you can see this is sort of the great listing of all the things that I put on the slide earlier. So we have general, compute, networking, storage, web. You can set up web services on here. Services for mobile devices. This uses a number of different containers. Kubernetes is one of them. This is another reason you might use Azure if you're using sort of these images. PSC will not accept Kubernetes or Docker images. PSC only accepts, what's the name of it? I don't know, I can't remember. But they don't accept sort of the commercially oriented images, but Azure does. There's a lot of different database options, analytics. Let's see, what do the analytics have? Yeah, these are analytics more oriented around business intelligence solutions, so administrative data and whatnot. Then we have our favorite category, AI and machine learning, Internet of Things. So anyway, you can scroll through this list for obviously a very long time to see how many services are available to us. But let's jump back here. So the process for getting on Azure is, like I said, you fill out a form at some point in the year. We confirm your access to it. Then we'll provide you with an email that has a link. You click through the link, you get an account, and then you're set up because I've already set up a resource group for you. Resource groups are what tie all of your resources together. You can make your own, but I usually set them up for you because you're usually doing it on a per project basis. I'll go ahead and look over at some of my resource groups that I have here. So we have resource groups for professors, which generally their advisees use to run these projects. Luca, who's present here, has his own research group. So we can segment these however you want. You can then add people to your own resource group if you want to work directly with them, if you want to give them control of your machines, for example. And if we click into a research group, I'm going to use you as an example here, Luca, because you have a couple different resources. So Luca here has NVIDIA V100 machine, which is a pretty nice GPU learning machine that he uses, again, when he needs it, so he turns it off and on responsibly. And then he's got another machine that is sort of more of a general purpose. Is that the best way? And that would be some of the setup jobs before the machine learning model or processing afterwards.
It was the machine that I was using before I needed a heavy duty NVIDIA GPU. So yeah, I mean, basically, for any kind of jobs that wasn't too GPU intensive, I would use the other one just because it's more cost effective, it's cheaper.
Sure.
And the NVIDIA V100 would just spin it up to train the model and train it up, basically. Because it's quite expensive, that one.
Yeah, sure. So in this case, Luca has his own dedicated machine that he can turn on and off for general purpose processing. It's got 56 gigs of RAM. The advantage here is that nobody else is going to be on this machine, right? You can add as many hard drives as you want. You can share hard drives between work groups if you're working with another group and they have data. It's a way to save money also, but it's also a way to prevent yourself from loading gigabytes of data repeatedly. So that's a little peek of a research group and the virtual machines inside it for a single person. I'm going to go ahead and create a resource now, so basically set up a new virtual machine, which is something that you can do yourself when you have an account. So the first thing that you get to see is all of the different types of resources, the list of which we just went through. I just want to create a basic virtual machine, so you just click create on it. And as we proceed through this, you'll see the screen change like a regular form. These particular things are something that Microsoft calls blades. So if somebody's talking about a blade, right now I'm on the create a virtual machine blade. It's not a screen. So the importance there is that you can slide back and forth through this, and I'll show you in a second, as you do this without hitting the back and forward buttons. It's just an interface quirk, and they will use that terminology if you're ever talking with them. I'll go ahead and use I'll use Chad's resource group. Yeah. So we'll just give it a name, call it test machine, and then here's another quirk. In different fields, it accepts different types of characters. So even if it's just a name field, this one will not take underscore. It won't take spaces. Will it take underscores? It will take dashes, and it will not take underscores. There's another field that will take underscores but won't take dashes. So just one of the many things that causes challenges here. Something that you'll want to do here, this Azure is a cloud environment. It's not meant just to have servers on. It's meant to have high reliability and high performance servers. So when you're building an application, which we are not doing, you generally want to have some type of redundancy built in. We don't need that. We just need the machine to be on or off. And it's a single machine. It doesn't have to back anything else up. So when it asks for availability options, you want to say no infrastructure redundancy required. Otherwise, it reduces your options later in the process. Everything else, let's see, the next step is choosing your image. So I think, yeah, the default image here is Ubuntu Server 20. They haven't added 22 yet, which is what our servers are running. You can upgrade that yourself once you get this installed. But as you can see, a lot of the licensing is actually taken care of, so you can use Windows servers in here if you'd like. But it also has Debian and Oracle Linux and Red Hat. I think everybody's just going to choose Ubuntu. I don't think the architecture is going to matter very much. That's a new option since a few months ago.
It might matter maybe if you have some installation locally on M1 that you want to replicate there, because the architecture is, bad.
Yeah, we'll have to check on that. We'll have to set up a test machine to see if that works.
It might be easier to replicate in the local environment on Azure if they have the same architecture. Maybe.
We'll add that to the list of things for the computing TA. No, that's why I got an M1 also, because I wanted to make sure that this is tested. But again, I haven't seen that option. That's a fairly new one. Yeah, so when you go to this, the next step is choosing the size of your machine. And that is your entire machine. So that's memory, basic hard drive, and processor. So it defaults to 3 recommended images, because whoever has published this image in the sort of selection area has these set aside as default options, but really any of these configurations will work on any machine. So we can go and look at all of the sizes. If we expand all of these arrows, you can see that there are probably hundreds of different types of machines. And the best part about this is that over in the right hand, it tells you how much they cost per month if you're running them 24/7. So the ones that were recommended, these are the most used by Azure users in general, $53 a month, which is, if you want your own server, that's pretty ridiculously cheap. That's pennies per hour. That goes all the way up to, here we are at $3,300 a month. And that's still general purpose. That's not with any special hardware. I mean, it does have 380 gigs of RAM and sorry, I'm zooming back and forth here. 96 cores. So if you need a job and you want to run it for an hour that parallelizes over 96 cores and uses that much memory, that's a great machine. That's actually affordable. But again, that goes back to your responsibility and your power. You have the responsibility to plan your projects appropriately. So if you want a smaller machine, like Luke is using, to test out various things on, and then go run it for a couple hours on a very expensive machine, that might be a really good use of Azure. You don't have to wait in a queue like the supercomputing center. You have more resources than Hydras give you, and you have full access to configure it however you want. And the only time you're getting billed is when it's on. So you could set aside an instance like this and just turn it off until you're ready to use it. For our purposes, I'll just choose a cheap machine with 1 core.
Where's the button above the spot discount?
Oh, right. So spot discount. Spot instances operate like AWS spot instances, which means you have requested this type of machine. If there's a machine available, you can actually run it for super low cost or free. But they might shut it off at any time. Yeah.
Oh.
So there's ways to optimize things if you are using spot instances, but it's better if you're using sort of the Microsoft ecosystem of products because they have more monitoring and metrics built in. Otherwise, you'd have to do it manually. Yeah, it's not, I mean, the machine can just stop.
Yeah, okay.
Yeah. The other thing here is how to log in. So the default that we've been using is using a public key for SSH. So we talked about SSH in the Linux session. But basically this lets you specify your username. Default is Azure user, so I'll just go with Skipper. And the rest of the options you can leave there. What this will do is download a key to your machine, and that way you don't have to enter a password. You just have to have the file that is the key in your account on your computer. You can leave the rest of these options as they are. So then there's the data disk. So by default, there's a operating system disk, and I'm not sure, I think it's like 40 gigs or 60 gigs or something. So it's actually good for most people who are just getting started to not worry about any extra storage. You can, down here in the data disks for test machine or for whatever your machine name is, you can add as many disks as you want. And again, once you add them, they're attached to this machine, but you can detach them and share them with somebody else if you're working in a project group. Or you can allow the disk to be connected to by multiple machines at once. So that's how it works if you're doing parallel processing, and we actually managed to get it to work to automatically spin up virtual machines, like if you wanted 100 mini VMs to use the same source data, they can all access the disk at the same time, just read only. Yeah.
Just a question on that. So if I have 2 instances, can I share one disk between them?
Yes. Yes. Good thing to know,
I
right?
share one instead of CP.
So if you come to my office hours, then everybody else can ask you what your office is. So the other thing that goes along with this, and this is the system administration aspect, is once you've attached a disk in Linux, it doesn't automatically do anything. It's just like plugging a new drive into your computer. It doesn't automatically format it. It doesn't automatically even detect it or necessarily. So once your machine is booted up, you have to go through and run a series of commands to make that disk visible to the operating system on this computer. And that is all written very clearly on our Compute Wiki. So there's step-by-step simplified instructions taken from Microsoft's documentation. And again, that's, from a system administrator standpoint, that's sort of a really easy thing to do, so I can help you with that as well. That is not Microsoft dependent, that's just Linux. And you do not have to worry about these other options either. The next blade here is called networking. You don't have to change anything there. It's totally fine for you having access from a remote place. You can set up a whole application behind a firewall and do all kinds of things that are totally not related to your research. So since I mentioned the word blade, it's not working the way it's supposed to be. Okay. Imagine that, Microsoft, sorry. Anyway, we'll skip this. We don't need to worry about load balancing, making sure this is high availability. If the network goes down or something, it's basically on or off as far as you're concerned. Now, as far as management, again, some of these things are for Windows, like automatically installing Windows Defender and making sure you're updated from Microsoft's local cloud. You won't have to do that with Linux. There is an auto shutdown option. You can make sure that in case you forget, it shuts down every night at midnight. The thing about that is you can't turn it off once you've set it for a machine. So if you're planning on doing something that lasts longer than 12 hours, you probably don't want to do this, which is pretty much the only reason that anybody wants to use Azure in the first place. So you can do this in case you're worried about something, but I would not bother with it. And the backup is also for Windows only. Then again, since we're using Linux, we don't really have to worry about a lot of the monitoring stuff. Hopefully we'll have more options with that come the springtime. The only thing that we have to worry about under the advanced area is if you're running a GPU machine, you need to install a specific driver. Even if you choose GPU as your instance, it will not automatically select this. So you have to click through and select an extension to install. And I've been through these. The only one we actually need to use is the NVIDIA GPU driver extension. The others are all for management or SSH with Microsoft's Active Directory service, which we don't use. So if you're running a GPU machine, choose that extension, you're all set. It'll have automatic access to it for PyTorch or TensorFlow or whatever you're using. So let's click next. No, I do not want to choose that.
I guess the difference is that once you install the driver installs a different GPU given the instance.
I'm not sure exactly how it works.
Because depending on the instance that you choose, you get assigned, when you install the driver, a different GPU.
Yes.
So basically, there is documentation that says, okay, with this CPU, we ship a V100. With this instance, we ship a V100. With this instance, we ship a Tesla K8.
Right.
Something like that.
So this you're saying this installs the specific GPU driver?
Yeah, you cannot choose here
Right.
which one.
No. Yeah, this is just the driver.
Yeah, I think it's just like in like Ubuntu, like in default Ubuntu, you don't necessarily have the NVIDIA driver in there, so this will just add the NVIDIA driver to the Ubuntu image.
Exactly.
I don't think it has anything to do with the hardware, like hardware is as is, it's just that just better you have the NVIDIA driver in as part of the Ubuntu image.
Yeah.
Okay, we will remove this extension since it wouldn't let me unselect it. There are ways to provision things and script creation of many machines if you want to. We're not at that point because everybody's running their own machines. So again, I don't think you have to worry about anything on this. There's no new buttons on the screen that I'm aware of. And so you go to review and create it, and so at this point, it's just getting all together everything that you've chosen, looking for resources itself, which is what the little activity bubbles there were. It tells you your hourly cost, so this is great. It's 7 cents an hour for one core. It'll probably work faster on your laptop, to be honest, but let's take a look at pricing for other VM sizes just for the heck of it. Let's see, one of the larger ones. So even for a server that might be comparable to a Hydra, that's $300 a month. This is probably somewhere where I should also mention that you can get your own campus cloud servers if you can secure financing for it. So you can get a machine for up to, and this is not advertising for Azure, obviously, this is our own services. You can get a cloud instance for a 128 gig machine with like 100 gigs of hard drive space and connect it to our local file server and just use it yourself for $100 a month. So again, Azure is supposed to be used a little bit more for if you want to control everything yourself, which you can do on your own instance, but also if you have specific use cases like large number of cores, large memory, immediate need, things like that. But we do have this other option for the Hydras if you want to get your own. Okay. So once we've verified all this information is correct, you can just click create, and again it gives you the little activity bubble. This is where it sends you your key to log in. You have to download this, otherwise your machine will be useless. If you lose this file, you can't get another one. So you want to download the key and finish creating the resource. And it takes a second, And so now in my downloads folder, I have this great new, let's see, what's it called? My test machine. Now it's in there somewhere. There it is. Okay, so it says here, I've got the key, the deployment is in progress. It'll give you a notification up here when it's done. It's actually a pretty good notification system. This shouldn't take more than a minute, to be honest, with this sort of machine.
Have you ever seen it would take a long time? Like, let's say if you want to deploy some fancy GPU machine and they might not have too many of those available, like, can it take a while?
No, it shouldn't take more than 5 or 10 minutes.
Okay, so they're somehow guaranteed to have enough machines that, you know, if everybody in the world starts to deploy certain types of GPUs, they will have the resources.
Right, which is why it's limited by your account type, rather than, I mean, they have enough computers spread across the world for anything. It's just, that's an organizational policy rather than an actual resource.
Okay, okay, so in practice, you never really have to wait very long.
Yeah, no, I mean, so this is complete.
My experience is less than 2 minutes.
Yeah.
Yeah.
Right, so right after this, just to show you, we can go to the resource, and it gives you a nice summary, just like whenever you click through on it. The key things that you need to know, especially when you stop and start a machine, are this bit right here. That's your IP address. That's what you're going to be connecting to. So what we want to do is actually use this, right? So let's go up here to this button that says connect. And we'll be doing SSH. Yeah, it's ready to go. So the key thing that you have to do is make sure that you have your key downloaded, which I've done, and then you have to open a terminal. And you can put the key wherever you want on your computer. It doesn't matter. Mine's in downloads, obviously, so I'm going to get in there. The other thing, and it says it back here, is you have to run this command in order to use this file. You have to make sure that you as a user are the only person on your computer to access that file. Nobody else can. And don't worry about the details, just type that command. So it's chmod, and then 400, which sets the permissions, and then the name of the file. Okay, so then that's ready to use now for connecting. And similarly, all you have to do is run that command there. So SSH-I, that means that you're going to use this key file to connect rather than a password. And my account, I need Skipper. If you didn't change the name, it's Azure user. And then it gives you the IP address. So you can actually copy and paste this and just edit the private key path. And then you type yes, just like any other new SSH shell. And you have your own machine. So you can, if you're running a specific software package and you have to come to me to install libraries or something, and you don't want to come to me anymore, you have complete control over this machine. So you can type apt install plink or whatever the package name is. Let's say libxml2 dev. That's something that everybody uses for various R packages. And if you want any help with system administration on this level, I'm happy to sit down and tell you everything. But I'm not going to do that in this presentation. So anyway, once you have that all configured and set up, you can use it just like any other Linux machine. You can set up an SSH channel to it. You can run Jupyter notebooks locally and see your results on the server. You can go ahead and install. I don't think R is installed on there actually. Let's see. Nope. So again, unless you start with the machine learning AI machine, you may have to install some of these things yourself, since R isn't automatic.
Isn't there an Ubuntu data science machine? Isn't that one of them?
Yeah, I didn't choose it. That's what I meant. The
Yeah, so
data
there
science.
is a specific data science machine that should
Yeah.
have these things.
In fact, let me back up here, and when we go to create a new resource, we can choose the AI and machine learning, and it's not, oh, there it is. Nope. I guess there's some new ones.
GPU optimized PyTorch image.
Yeah, so there's a PyTorch one, there's a TensorFlow one.
I think you had, if you search Ubuntu data science, something like that.
Yeah, it used to be right in this, there it is, data science virtual
that's
machine.
the one we use.
Yeah. I don't know why it wasn't showing up in that list.
See, there's like PyTorch,
Yeah.
what else does it come with? Okay, yeah, see, so it has all the kind of the users.
Yeah, so this is the one that we sort of, again, a lot of people have come to this to use GPUs. I don't know what other people's experience has been with the general purpose ones. Did you have to install R on the other one?
I usually don't use this one because if this will install PyTorch across everything, but I usually maybe need like different environments with different versions.
Okay.
And so I usually just spin up the usual Ubuntu, and then within the environment I install what I need.
So that's another great use case for Azure. If you need to have 2 or 3 different machines and you can't set up a different environment for a specific project on one machine, you can have 2 or 3 different environments.
So you start from vanilla Ubuntu?
Yeah, vanilla Ubuntu, and then I install Conda, and but yeah, this will do as well.
Yeah, so if we jump back home, you can see the newly created test machine was a recently accessed resource, and you can jump back into it. And when you're ready to stop using it, just click stop at the top, and then you're not paying for it anymore. We're not paying for it anymore.
Maybe it's worth mentioning that you don't lose your data.
Right. So the storage anything that you've put up there, unless you terminate your machine, let's see, just stopping the machine will keep your entire machine configured and ready to go, and not being built. Your data and your code will stay there for the next time you turn it on. If you delete your machine, I think you can actually, so you can actually choose to keep any disks that you've been working on. So if you've decided that this machine isn't working for you, you want to start up another one, you can just go make another one after deleting this one and choose this OS disk that you've already configured, because it's in your resource group so you can see it, to be either the OS disk for the new machine or as just a separate data disk. Yeah, that's about it. That's the basic getting started. You can click through these tabs and see all the different settings. The ones that you probably primarily use are disks, where you can add or share disks across different machines or people. Any other questions before you just come to visit us and read the wiki? Read the wiki first. All right. That's it. You can stop the recording, Mike.
Okay.
No.